Thank you for coming. I know today's probably been a long day if everyone was here since keynote in the morning. Thank you for coming. Late in the afternoon is always difficult. I was having a fun conversation beforehand. I didn't want to necessarily be here either. Like at this point, like I'm typically an introvert. I like talking on stage and giving kind of background on certain things, going into detail about like how like Spark works and things, but I'm not necessarily like super communicative in general. So anyways, I'm happy that I'm here too. I'm happy that you're here. So let's just kind of get into it. So Spark Inception was an idea on creating basically a remote controller for like the Spark shell. There's a talk this morning about basically Spark Connect. It's like how do you run remote procedure calls, or how do you run like remote frames, like in terms of individual cells of code. How do you run those remotely? So what we're going to do today is basically just talk about how to build a streaming notebook environment that is just remote procedure calls that are being rendered internally in Spark. So we're starting off with no application. We're ending up with an application, but we're doing that all on the fly. So in the same way that you've seen like with Apache Zeppelin, or if you've seen with like Databricks notebooks, or Jupyter, or Polynote, and the 1,000 other notebook environments, this is the same exact thing, showing you how to run, basically build the same exact environment end to end using just Spark. So let's get into it. That's working. Other way. All right, I will do a manual. All right, so I'm Scott. I was just introduced. I'm a Databricks Beacon. I've been working with Spark for 7 years. I've been working in streaming systems now since like 2012, and I really like data. I also like hot sauce. I make my own bespoke hot sauce, which is a weird thing to say. I have a small garden in San Jose, and I make like 20 bottles a year, but it's a hobby, and it's something nice to do, which I picked up I got better at it during the pandemic. I also wrote a book last year on how to build basically modern data engineering like systems using Apache Spark. That was a labor of love. If anybody wants to buy it, feel free to buy it. I have a couple of copies I didn't bring here. If anybody wants one, I've got like 3 to give away, and I can go grab them out of the speaker lounge afterwards. So that's there. If anyone wants a free book, you can get a free book. All right, so plan of attack. We're gonna talk a little bit about what a notebook environment is. We're gonna talk about how to actually build a streaming notebook application, which is literally just gonna take individual cells, like creating a data frame, creating new case classes, and doing all of that on the fly. And I'm gonna show you basically a demo that hopefully works at the very end. And there's also take-home material if anybody else wants it. So there's Docker containers if you wanna be able to go run this without actually compiling anything. And there's also the entire source code, which is on GitHub as well. So at the very end, there's gonna be more links. I don't know if anyone can see the bit.ly at the bottom, just bit.ly Spark Inception. If you want to go download the source code and take a look at that as well. So without further ado, prior to getting into the notebook environments, people might have seen the movie Inception. Inception just means it's a starting point. It's a place where things begin. So if you think about the birth of a new idea, the birth of a data pipeline, birth of some new novel idea, all that's basically under the umbrella of Inception. So what we're doing is creating a Spark application that allows you to basically incept new ideas and basically generate things on the fly. I'm probably gonna run out of time, so I'll just kind of quickly go through like the background. So notebook environment started from like the scientific method, where people used to have a hypothesis, you'd run a bunch of different experiments, and then you'd try and basically record your results and measures so that you'd have a repeatable process that basically turns an idea or hypothesis into an actual law. So notebook environments was a way of codifying that same exact process so that people don't have to worry necessarily about how to reinvent the wheel every single time they want to do exactly the same thing. So notebook environments, for people that use them, they're mutable. The application I'm going to show you how to build is also mutable. Mutability is terrible if you want to actually have consistent results. But it's also, given that you can kind of do things behind the scenes, you can add guardrails for people. Being able to kind of inject code on the fly with guardrails is something that's a kind of interesting side effect of being able to actually, I don't know, I have a better word for it. It's late in the day. So Let's continue. So popular notebook environments, as I talked about before, you've got Jupyter, you've got Databricks, you've got Apache Zeppelin, Polynote, and a bunch of other ones. The actual notebook itself is consisting of just individual the notebook has paragraphs. Paragraphs or cells are just code. It's either SQL commands, it's Scala, it's Python, or it's like Markdown to be able to describe what's going on within like that actual notebook. So the environment itself allows you to focus on like what your software should do versus all the other stuff that's like difficult to actually run, actually have compute, everything else like that. So it basically helps you save time. So if a notebook environment helps you basically quickly test ideas, going back to the scientific method, you have a hypothesis and you can basically test your ideas interactively. Interactively means you don't have to actually go back and compile, re-upload, that whole entire wheel. That's why notebook environments are really cool. They can be dangerous, but that's also kind of fun. So each code block is a paragraph or a cell. It's stitched together procedurally so that you're basically composing a final application as a series of individual steps that can be modified interactively. They can be modified on their own. You can do amazing things on like the edges and the border. So it's kind of on-the-fly data engineering, depending on what you want to do with it. It can also be on-the-fly data science as well. So I know I just talked about this, but if we think about like the anatomy of a notebook environment, what does the anatomy of a notebook environment look like? It starts off with a blank slate. There's nothing there. So it's your idea. You're going to start and do something. Traditional examples of how to actually use a notebook usually start off with reading data, doing a selection, maybe graphing something. So that's what we're going to actually, I'm going to show you how to build that. I'm probably not going to be able to go into all the details, but I'm going to go through as much as I possibly can. So what we're going to look at is creating commands that either render Scala directly, going back through the Scala I loop. So if you've used the Spark shell before, all we're doing is basically hijacking the Spark shell. And if it's running Scala, if it's running SQL itself, we're basically just piping that stuff back into the SQL context. So if you've ever taken a look at the Spark session has a SQL parameter that all it does is take your SQL and actually generate a logical plan and run commands from there. So anyways, going into basically a recap. So we have a notebook environment. It helps us move fast. We can test and share ideas without the trouble of like a local developer environment and the pain associated with like reconstructing the same environment. All right, doing good on time. So the crux of everything is now building the actual streaming application. So streaming notebook application is no different. This is no different than like a non-streaming notebook application. The only thing is that it's using Spark structured streaming to be able to have like a RPC channel to send messages back and forth. So we're going to define now what the application looks like. I'm going to go through what the actual RPC commands are. And then we're going to walk through the individual components from basically how the application is bootstrapped. And then what the chain of events is from individual command to processing of commands to rendering an application that didn't exist until you actually built it. So what we're doing is taking advantage of the underlying Spark REPL. So if you've used the Spark shell, I just wanted to throw this up here. If you've literally used bin Spark shell, you're using the Spark REPL. The Spark REPL itself is just a class, and the Spark shell just invokes a copy of that class as a Spark application. So given that there's an actual class for the Spark REPL, we can actually now remote control that through our Spark application. And that's what we're going to do. So quick architectural overview for what the application is right here. So basically we have Redis and Redis streams. Has anybody used Redis streams before in the room? Got a couple hands, which is good. Redis streams is awesome, and it's also really lightweight as a columnar, basically columnar stream. So in terms of having something that's fairly trivial to basically set up to demo and have people use, Redis is an easy solution for basically just a message bus. So we're going to have RPC for a request that's going to go over Redis streams. That's going to hit our Spark structured streaming application. So literally, I'm going to send events through Redis directly through the Redis CLI. Other people could potentially wrap that in as an API, and then that will do things on behalf in a more secure manner. In this case, it's just going to basically be like an end-to-end CLI, which is kind of ugly compared to like a nice notebook UI. Probably asking why you'd actually want to do this, and you just want to do it because it's actually fun. So that's why we build a lot of things, is for the fun of it. So I literally created this presentation, and I didn't know if anyone was going to actually pick it up. They picked it up, so I built it, and now I'm talking about it, which is kind of fun. So anyways, we have RPC, comes through, creates a thorough structured streaming application. Are people familiar with like the for each batch in the write stream, like from like Spark Scala? So for each batch allows you to basically get to your underlying data set. We're going to collect that stuff back to the driver. On our driver, we have a Spark shell that's running behind the scenes. And then we're going to dynamically create stuff and basically create more basically new DAGs on the fly, which is fun. So the results of everything that we're done, everything that we do within the application is actually going to be written back just as a Redis hash set, so that we have basically kind of end-to-end. What is our request? We're processing the commands. We're evaluating them, and then we're just pushing data out into Redis so they could get picked back up from any other application that's non-Spark. Like it could be a Java application, Python, Flask, it doesn't really matter. All right, so our RPC. So we know that we want to send something. We know we have case classes. Case classes can be evaluated through Spark's expression encoders to be able to convert them into struct types, which are like the data structure behind like the data frame itself. So we're going to be taking events from Redis, constructing these network commands as a way of basically creating something that we can work with that is concrete. So I have a network command. It's going to have a notebook ID. We don't have more than one notebook in this example. I just put the stuff here as like a kind of food for thought. So if you have a notebook identifier, you've got paragraph IDs. Same idea as like having individual cells within your notebook. There's a command which is going to be blindly evaluated, which is super cool until it's not. And then there's also like request IDs, so you can track like what's inbound, and then how that actual, how does this request to response work? And then there's an optional user ID, which I'm not going to go into. There's like really bad auth here. So as long as you know like the Spark user, or basically the user context of where like the actual like Spark application is running, then you can run any commands. It's like a really poor auth decision, but it's something that works and is kind of fun to play with. So we have a command. There's a potential user. It really doesn't matter that much, but if you don't know the actual user within like the Spark context, it'll just basically block your command as like a kind of idiot's version of security. So that's basically RPC in, so command in, and then like our response out is just like this, it's a notebook execution detail. So we have notebook ID, paragraph ID, command, request ID, all the same metadata that we passed over. And then we also have a command status, like was it successful, was it a failure, did it error out? And then the result is like the actual results of processing each individual cell in this notebook. So if we had a UI, if I knew how to write UIs better, then we could potentially have a UI that's powered by this whole entire application. But for now, it's just going to be like all in the command line. So I'm going to kind of walk through this part kind of quickly. So who here has written a Spark application? Cool. Most people have written a Spark application. So Spark Scala, do people here use Spark Scala, or is it more kind of Python? So this would be fun then. So this is just some Scala. All this is doing is it's just creating a pipeline. So we have an output stream. The code itself has a better overview of how all this stuff is actually working. So this is just wrapped really quickly. Part of the way that this stuff works is in the book that I wrote. So instead of talking about 600 pages worth of stuff right now, I'm just going to fast forward and talk about this a little bit faster. So we've got a network command processor that's processing network commands. We just took a look at like the RPC for our network command. So that's loading our input stream, which is just our Redis stream. And it's loading that as a network command, which is just taking our Redis data from like the Redis stream, and it's basically giving us a data frame that we can work with. In this case, it's a data set, so that we can actually use the JVM behind the scenes. Then we're running a for each batch, and then we're going to process each individual batch. So data comes in as a micro batch. For each batch, we're going to process data. So within the process batch method, all we're doing is saying, I'm going to pipe this to what I'm calling the Spark remote session. That's a controller for the Spark iLoop, which is the way that we're evaluating code on the fly. So we're taking a string and we're evaluating that as now, dynamic, generated like Java classes or SQL commands and things like that. So for process batch, this is basically part one. I'm going to show basically kind of from start to finish what this ends up looking like. So we take our command, we process it, and then afterwards we're just creating that output RPC, which is like our network execution detail, just so we can kind of stamp the metadata of what actually happened. So for each micro batch, we're collecting the data, we're evaluating each individual command, and we're just repeating this forever because it's a stream running micro batches. So the way that this actually works, given that when you're running things distributed, you don't actually have like a Spark context that you can get back to. The Spark context only lives on the Spark driver. So given that we know that we have a lightweight protocol, given that we can actually clamp down on the number of individual commands coming into the application, it's in the config. We're only taking 10 at a time. So being able to process that and bring it back down to the driver is not going to give an out-of-memory exception. So all we're doing is we're calling collect on our data set, which is saying collect everything from the executors and bring it back down to the driver. And now I can do interesting things with it because I know exactly where I'm processing this code. So I'm basically redirecting the commands, and then we're going to run those either directly through like our Spark SQL context, or we're going to run that through the iLoop and generate new DAGs on the fly. So I circled the Spark command and also the Spark SQL command. So we're taking, I'll show you what the commands look like as I go into the demo, and then we can talk more about that as well. But if you think about a notebook that has like modulus SQL or modulus Spark or modulus MD for Markdown, that's basically like a header. You can parse the header and decide how you're going to actually process the code within. So in this case, I'm supporting either Scala or SQL. And that's pretty much it. It's a fairly trivial kind of demo. So we'll take a look at each one of these commands. So for the first one, for processing Spark Scala, we just take a command string, and we're just returning a tuple of basically a string and a string. So the Spark iLoop, which is the Spark shell, is interpreting the command so that I don't have to do Java code gen or anything else on my end. It's going to compile everything, and it's going to ensure that everything is available to me within the Spark context. So I don't have to do any work. I can be lazy, and that's perfect. So that's what our jobs are, be lazy where we can, and this actually helps with that. So I interpret my command. Are you familiar with, who here is familiar with like the compilation like in Scala? Perfect. I'm going to skip that. We're not going to talk about that. So basically, if you think about like a Spark, like the Spark shell, you run a command, it's going to come back to like standard out. So in this case, all we're doing is taking standard output, and we're just redirecting it back so that we can copy the actual output buffer of data from the shell, but now we can actually own it. I'll show you what it looks like in just a sec. Take my word for it. So then in the case of Spark SQL, all we're doing right here is taking our Spark session. So I have this process Spark. We've got try app Spark session. And we're just calling the SQL, we're just basically calling the SQL function directly. And again, we're blindly passing more data to that. We're trusting that Spark does the right thing. Given that we're actually calling everything in a try, if anything problematic occurs, we can just spit those problems back out to the console, and it becomes somebody else's problem. So, which is always good too. So in this case, if you want to try like a new SQL command, you don't know if it's going to work yet, you don't know if your joins are going to work, or if you have the right tables, that's also cool, because it's going to basically fail fast. So you don't have to worry about anything like smart. So be dumb, it's all good. That's what this app helps you with. So process batch part 2. And this is kind of a weird presentation. Thanks for kind of going through all of this. It's a difficult concept to talk about in 30 minutes. But so we had a network command that came in. That's great. We have a micro batch. That's also great. We've processed all the individual commands, and we've done all the work that we want to do for our individual batch. And now at the end, all we want to do is basically write that information back to Redis. So that's basically, our output so we can see what happened because we don't have a UI. With a UI, things become a lot easier. When you don't have a UI, it's a little bit harder. There's a lot more kind of moving pieces. So in this case, what we're doing, so if we remember, we collected all of our data back down to the Spark driver. That's awesome until we want to do something else with it, because right now we don't have a data frame. So because we're on the Spark driver, we know that we can go back into the Spark session. We have the context locally, so we can easily go and create another data set and then do more fun stuff with that. So in this case, all the results of our execution are now being written back to Redis, and that's pretty much it. So we now have an output stream that we can actually get back to. So is everyone following a little bit? Yes or no, kind of? And it's a complicated topic. But we're going to go through the demo, and I'm going to show you how this stuff actually works. So just remember, we had an input stream of network commands. We're processing those commands, and then we have an output stream that is like the end results of our process commands. And it's actually, that's pretty much all you have to do with this. So, all right, I'm going to attempt to end this part of the show, and then we'll go look at a demo.
And so from the audience, whilst we're waiting for our lovely demo, are there any questions that have come up so far? All right, I'm going to run over with a microphone so the people at home can hear you. Yeah, just present to a few hundred people, thanks.
Perhaps a random question, but what was the hard technical or curiosity thing that drove you to build this demo?
So pipelines are difficult, and having like 100,000 different pipelines running, the idea of being able to like define that through code and auto-generate similar pipelines that actually had guardrails. So if you think about like, I want to go and I want to query a database that has 100 million rows in it. If I'm not limiting those calls, I might accidentally run out of memory, and I'm not going to be able to know until things break. So being able to kind of inject around the edges was the idea.
Is that the micro batch?
So this was like, so if you think about kind of like at like a very high level, any kind of like ETL pipeline or ELT pipeline that you want to create, being able to kind of streamline, like a base application was the idea for all of this. So you can run repeatable code that's basically like config driven. But in this case, it's also kind of a fun thing to showcase, but I don't know, the demo is going to be TBD.
DOA.
It's going to work eventually. Someone say dead on arrival, that's all good too. Anyways, the whole idea was literally just to understand how do you build a notebook? Because I was like, it's a curiosity, and I had no idea how it worked. So I dug into how it actually works to try and build one. Not to like go create the next Zeppelin or do something. It was more just as like a curiosity thing. And if it works, I'll show you how it actually works. Otherwise, I can just kind of like mime some stuff up here in the meantime. But essentially, I'll just walk through like the commands. So the commands are, in the case where we have nothing, because we've just started this whole entire application, and we want to run our first line of code, I'm just doing something, it's just show tables. I know for a fact I have no tables, there's nothing in the SQL context, nothing's loaded, so I get an empty result. Cool, my first command is an empty result, that's awesome. Next command is me basically saying, okay, well if I had nothing, I want to start off with something. So I'm defining a case class for people. Anybody who's gone through any of like the Spark docs has seen somebody define a case class for people. We've got a name, we've got an age, we might have other information. But because that class didn't exist before, it has to be defined. So that class will be defined inside of like the Spark iLoop. And then that ends up being available for us now through our command line. So if we create a case class for people, then we can go and create a sequence of people. And so if I go and create a sequence of people for myself, my dog Willow, and my dog Clover, this is all from the stuff that you'll see eventually. We basically have 3 items. So there's 3 people. Of those 3 people, after we've defined the sequence, we're creating a data frame from those 3 people. And then we're saving that off as a table called people. So we went from having no tables defined to having a, yes. All right.
Hey. Woo, thank you very much.
Thank you, guys. I'll just look at that one. Okay. That's fine. I blame it on the M1. So it's an M1 laptop. It works until it doesn't. OK. So to answer the question from before with a visual, what the demo, I'll see if this might be difficult. So we've got a command sequence. So the command was show tables. The second command, if you think about these as notebook cells, is case cost person, people, defining our data frame. Now we're creating or replacing like our temp view for people. The third command is now just selecting everything from people. It's a super simple and trivial like example, but it showcases how to use basically how I forward everything to either Spark SQL or how I forward things to Spark Scala and actually do magic. So let's take a look at magic now. All right. Sorry, my eyesight's terrible because I'm old. All right. So right over here, let me exit out of Redis for a second. So my first container, going back to the mental model that no one has other than me right now, we have Redis on the left-hand side, and that was a Redis stream. And that Redis stream is going to be the way that we pass our network commands. So I'm just going to show right now that we have either no keys. In just a second, we're going to have no keys. So if I do flush all, I'm going to have no keys. So keys are gone. Awesome. So with Redis, right now I have an empty data set with nothing in it, which is awesome. So I know that I'm starting off and I'm being honest and I don't have anything else prepared. Over here, I have my Redis Monitor. I'll show you how that works as well. So it's basically just running in a Docker container. So my monitor is just showing every single process that's happening. But I also have my application running because I was cheating. So I'm going to turn that back off. And let's take a look at this in just a sec. So see if my keys are back now. Good, they're still empty. That's awesome. Monitor is still there. So now I know what's going on. OK, so going back, mental model. Left-hand side was our RPC for Redis. Then we have like the actual Spark application itself. So I'm going to go run the Spark application. I'm just running it in Docker because demos don't usually work well without containers. So this is the same container that's available in Docker Hub. So I'm running it. I'm opening up port 4040 so we can take a look at the actual Spark UI. And now I'm running the Spark Inception controller. And then also, all I'm doing is basically piping Spark submit as well to my local jars and my local config that we might have time for. I've got 5 minutes left. So we'll see if we get into all the config. Otherwise, it's very well documented on GitHub how everything else works. And I can talk to anybody for as long as you want after the session's over. So what we saw right there was starting a Docker container that's running a Spark application that's now running a Spark structured streaming application that's been configured to read off of Redis for our Redis stream. The Redis stream is going to be taking our network commands that we haven't created yet. And right now, there's actually nothing running in our application. So to prove that nothing's running in the application, we're going to go and open up localhost 4040. This is our Spark app with nothing running right here, which is great. So now we actually want to go and run something. So if you consider this as a blank slate from our notebook, going back to the earlier slide that is in my head, hopefully people are getting it, we have an empty notebook with nothing in it. And that's awesome. So going back to my commands, because I can't type it all because the commands are kind of hard. So our first command, right over here, so xadd is basically a stream object in Redis. If there's no stream defined prior, xadd can actually generate a stream on demand, which is cool because then I don't have to do anything for this demo other than just run this one command. So I'm creating a new stream. It's called notebooks v1 notebook 1 RPC, basically for my streaming like ingress. And then after the asterisk, you see like notebook 1, paragraph 1, command is that SQL show tables, request ID, all that fun stuff. So I'm going to copy it. And that's equivalent to the first paragraph, or the first notebook paragraph over here. So I run that over here. The Spark application runs and takes the command. You see that I have like these like xinfo, xadd over here. and now it's actually processed the command, and I get back a status where it's a successful command, but it did nothing because we have no result because there's no tables. It's working as expected. So second part is now going and actually defining our individual person class. If I can copy and paste, which is the hardest part of this part. So this is the command 2, which is a procedure of basically 4 lines of Spark Scala code that we want to now go and process. So second part is running. It's defining classes. It's doing all the work behind the scenes. And it's now already complete as well. So we have all this other information over here. So if I go and take a look at like my keys now, I have my stream. I've got paragraph 1, paragraph 2 within like notebook 1 and my RPC channel. And then like the last part is basically just selecting everything from people. So if I go through, copy all this over here. We run our third command, taking a look at like people. Then that's running over here. That finished running. So now if I take a look at like the individual keys again, I should see paragraph 3. And this would be a lot nicer if it had a UI. But if I do hgetAll, it's a hash get on all the individual keys. And then so you see at the end, like you have a result and it's just JSON serialized data that we sent to the application. So that's pretty much it for the demo. It's, yay, it worked. All right. So hopefully that, I don't know if that was like super helpful or not, but it's a remote controlled streaming notebook environment that pretty much does exactly what a Databricks notebook would do or like Zeppelin or anything else. But now everyone can build it themselves. So we've got 1 minute and 30 left. Does anyone have questions? Or I can try and put the slide back up. I can tweet afterwards as well. Or if anybody wants, hold on. Let me just not present since this screen's still showing. So after demo time was this part. I don't know if that's big enough. So if you want the code, it's bit.ly Spark Inception. Yes. We're gonna try and play from current slide. Did it work? All right, yay. All right, so GitHub, all the code's there. The only caveat is that you have to run the Redis container, which is unfortunate. It should be a test container, but I didn't have time to make it easier to use. Then like for the Docker, it's just basically the final container. And there's also a README for how to actually run everything. So that's pretty much it. And hopefully this was useful. I had a lot of fun writing the application. It's fully functional, it's fully tested. So if you want to understand how to fully test Spark Scala applications or build neat things, it's all there. That's it. So.
Thank you very much, Scott. First of all, I'm super glad that you had fun making this because watching you mime out how your demo is going to go, like I didn't expect to see that during this week. So thank you very much.
You're very welcome.
So for everyone in the room, obviously Scott does have a bit of time, and for everyone at home, you've got all the details on screen if you'd like to get in contact with Scott. So once again, thank you very much for joining us.
Yay!